Now question 4. Other than temperature, state two factors that determine the rate of a chemical reaction. Now this was covered in Form 4 under rates of reaction and reversible reaction. And so here several factors were discussed that affect the rate of a chemical reaction, one of which has been mentioned, which is temperature. We can list the others. I hope you can recall all of them. Pressure, particularly for those substances that are in gas form. Light intensity, the intensity of light. Light intensity. Surface area. I write SA, you notice it is surface area. Concentration, you should not forget. This is a very important factor. There is also presence of a catalyst. Surface area, light intensity, pressure. Those are just but to name a few. Subsection B, a solution of hydrogen peroxide was allowed to decompose and the oxygen gas given off collected. After 5 minutes, substance G was added to the solution of hydrogen peroxide. The total volume of oxygen gas evolved was plotted against time as shown in the graph below. We have a graph, yes. On the vertical axis we have volume of oxygen. On the horizontal axis we have time in minutes. Okay, if you do you notice something about the curve at this region? It suddenly rises. The curve rises, and yet it was coming steadily. So we get to the questions, scroll down to the questions to be able to answer them correctly. Now, Roman 1, describe a procedure of determining the rate of a reaction at minute 12. So this is rate at a point. There is a difference between rate at a point and rate over a certain time lapse. So rate at a point, to determine, we have to give the steps. So first, draw a dotted line parallel to the vertical axis. And then construct a tangent. To the curve at the point of intersection between dotted line and the curve, and then determine change in volume, and similarly change in time along the tangent line. Then determine the gradient or slope of curve as change in volume all over change in time. That way you will have calculated the rate of reaction at minute 12. How does production of oxygen in region AB compare with that in region BC? Explain. Production. So production is actually the rate. So we can say rate of production of oxygen in region AB is lower than rate of production of oxygen in region BC. Explanation. A catalyst had been added in region BC. That is the point. Now, subsection 3, write an equation to show the decomposition of hydrogen peroxide. Hydrogen peroxide naturally decomposes, giving water and oxygen. However, this process is quite slow. Unless you add a catalyst, this process, the rate of reaction is quite low. So, subsection C, sulfur 4 oxide reacts with oxygen to form sulfur 4 oxide as shown in the equation. Sulfur 4 oxide, oxygen, we get sulfur 6 oxide. This is sulfur 6 oxide. The enthalpy change here, you can see the sign is negative, indicating that the reaction is exothermic. So the forward reaction is exothermic. The backward reaction will now be positive, which is endothermic. That is how we do it. If forward is exothermic as indicated by the negative, then the backward is endothermic. Explain the effect of yield of sulfur 6 oxide of lowering temperature for this reaction. Now, the effect is the yield of sulfur 6 oxide increases. Lowering temperature shifts equilibrium to the right, since the forward reaction is exothermic. I don't know whether you realize that, because according to Le Chatelier's principle, if a stress is exerted to a system in equilibrium, the system adjusts so as to oppose that stress. So if you lower temperature, then the reaction will shift to the direction that will favor production of temperature, so that it is opposing that. So that is it. Subsection 2, name one catalyst used for this reaction. The catalyst used is, we have platinum, although platinum is easily rendered inefficient, meaning easily poisoned. We have vanadium 5 oxide. Vanadium 5 oxide. We have also platinized asbestos. Platinized asbestos. Platinized asbestos is another one.